Welcome to lecture 12, input output port programming of 8051 using embedded C. In 8051 totally 4 ports are there, port 0, port 1, port 2, port 3. Each port consists of 8 pins, so 4 into 8, 32 IO pins available in the 8051 microcontroller. In that 32 pins you can connect input as well as output. Input in the sense switch, sensors, keypad, ADC support, you want to interface with the 8051 ADC, and output you can connect buzzer, LCD, LED and 7 segment display, so on. The first program, write an embedded C program to monitor bit P1.5. If it is high, send 55H to port 0, otherwise send AAH to port 2. The first is a header file. Why I am using the header file over here? Because I am using the port 0, port 2. It is a part of SFR register in 8051 microcontroller. So have to be use this header file as include reg51.h. The next I am using the S bit. S bit is a keyword or data type used to access the single bit in the SFR memory organization. So P1 cap 5 is assigned with my bit. You can give any other name also, no issue. My bit is equal to P1 cap 5. Void main, void. Initially my bit is equal to 1. While of 1, it is an infinite loop. I am writing the logic statement over here. If my bit is equal to 1, it will keep on, it will check the bit P1.5. If it is high, it will transfer 55 to port 0, else P2 is equal to A. Let's come to the Keil software. Just we will execute it. How it will work? Let's see. This is the embedded, Keil software. I am compiling. There is a one error over here. This is small v. One more. I used to be close. One more bracket. I hope now it will be fine. 0 errors, 0 warnings. Target. After that, rebuild it. Now I am going for the port, or is it the debug option. I am using here port 0, port 2 and port 1. Port 0, port 1 and port 2. This is port 1 is a input port. Okay, it will check P1.0, 1.1, 1.2, 1.3, 1.4, 1.5. It is always the program has to be checked. If it is 1, send 55 H2 P0. If it is a 0, send AA to the port 2. I am going with the stepwise operation. Now check my bit is equal to 1. That means P1.5 is equal to 1. So the condition is true. If P0 is loaded with 55. Suppose I make this bit as 0. Again has to be run. Check the condition. My bit is equal to 1 or not. It is false. Come to the else statement. So P2 is loaded with A. Okay. Then go for the second program related to the port programming. Door sensor is connected to the P1.1 pin and buzzer is connected to P1.7. Write an embedded C program to monitor the door sensor. The sensor is connected with P1.1. When it opens, sound the buzzer. You can sound the buzzer by sending a square wave of few hundred hits. Now they include reg51h, void main. I am using one sub function. That sum function I used over here. So this is a syntax void. What is the function name? ms delay, and here I am using unsigned integer. I declare over here. Yes, bit D sensor I connected with the P1 cap 1. The P1 cap 1 is assigned with the D sensor. The buzzer I connected with the P1 cap 7, that is assigned with buzzer. So void main, if D sensor equal to 1. So 1 in the sense while it is open. I am writing initially it is initialized with 1 p 1.1. The program while, because I am writing inside the infinite loop, if d sensor equal to 1, it means open. It will, what is that, buzzer 0101 with some time delay. It means on off on off on off. When it is ms delay function is execute, it comes to this sub function, it is has to be execute. Here unsigned in with the one variable. Here I mentioned as item. You can give a b c whatever it may be, and whatever the value I am passing over this function 255, that 255 is assigned with this I time. I use unsigned int I comma j for loop. The next the next one is j. So it will be going to be execute until this condition is going to be failure. It is nothing but it create the delay with the help of for loop. Now I'm going to execute with the help of Keil. How it works, we'll see. The Keil software. I am copy and paste over here. That is 0 error 01x build rebuild. Again I go for the debug. The output I am using here the two bits, one is p1.1 1.7, so no need of other ports. Okay, if p1.1, this is a p1.0 1.1 is 1, what is that? The buzzer is going to be high low, that is which pin p1.7 I connected the buzzer. To check the condition, yeah, condition is true, so p1.7 is go for run operation. I hope I not copied the delay function, that's why is the delay function I missed over here, that's why it is not executing properly. Now I over, yeah, now function, now 0 error 0 warnings, and text file created. Now I go for evaluation mode p1, yeah, p1.1 I connected the sensor is 1, it is open, it going to be give the buzzer sound. Here I pass the sub function, that is ms delay 250. After that buzzer 1 ms delay 250. Whenever executing ms delay, it go for some sub function. Whatever the delay we mentioned using the for loop, it is going to be execute that much time. After that again come back to buzzer 1. After that delay. After that 0 delay 1 0, because I return inside the while loop. If d sensor equal to 0, it come out of the loop. So this many times has to be run, it will take time. I am going to be run it. The buzzer is, what is that? It is going to be on off on off on off. I suppose I make p1.1 as 0. The condition is false, so it is come out of the loop. I am going for the logic analyzer. For on off, I want to show the square wave. Here setup. Here which pin I am going to be see the output p1.7, capital P 1.7. Has to be stop the simulation. Again once again I run the program. I going for the logic analyzer. You will get this oscilloscope window. You can able to plot the square wave, triangular wave, whatever the wave you want, you can. Here P 1.7, P 1.7, close. I am going to be run this one. Here 0 to 1. Yeah, now I got the output. I'm going to be stop this one. So off, on, off, on, off, on. So that is the buzzer is over. Here, if P1 is 0, it automatically it is what is that going to be P1.1. Sorry, yeah, P1.1 is 0. It is going to be stop. It come out of the loop. You can measure with the help of the probe. The cursor is there. The cursor you take, you can check what is the time over here, on time, off time. After that you can calculate the frequency and time period also. The next program, third program, write an 8051C program to turn bit P1.5 on and off 5000 times. It is easy. Yes bit, my bit 095 is assigned with my bit. I am not used P1 cap 5. Instead of P1 cap 5, I am using 0x95. Here I am not using any header file because I am not using any of the SFR register. That's why no need to declare the header file. So 095 I was to show where it is. This is a P1, P1.0, 1.1, 1.2, 1.3, 1.4, 1.5. How to represent with the S bit P1.5, you can define with some other name. Here what I done is S bit, my bit is equal to 0x95. That is also a syntax to define that particular bit. Here S bit, my bit is the name. You can use any other name, no issues. 0x95, or else you can keep P1 cap 5. It is also the correct syntax of this program. Void main unsigned integer is that unsigned integer. It is a 2 byte. Range from 0 to 65,535. That's why I am using unsigned integer z. So it will execute 0 equal to z equal to 0. It is true. Come over here. It will make this pin as 1. After that 0, again it goes to z plus plus, that is increment operator. Again over here 1 less than 50,000, sorry 50,000, it is true. Again come over here until this the function is, this for loop is going to be get what is that, fail. Until that this is going to be executed. Once it will cross this value, it come out of the loop. Now I execute with the help of the Keil program. You can get the clarity. Zero error, zero warning. Now this 095 is part of, I used to be debug. This is a part of P1. Fine. This is not required. Just adjust my window. Now just you see 095 is nothing but 1.5. This bit is going to be high low, that is 1010 for 50,000 times. It will once this will reach 50,000, it comes out of the loop. I running this function. Okay, it is within a fraction of a second. I will execute the what is that, the entire function within the millisecond. It close the function, and what is that, it will stop the operation. So now I go for the step by step operation. You can able to see very easily. Okay, now I'm going for, yeah, my bit is 1, the next my bit is 0 over here, P1.5. Again come to the increment operator and check the condition. If it is true, come to 1.1. Yeah, fine. Okay, 1010. How many times it will repeat? It is 50,000 times. The next program, still now we use only the single bit in the port 0 or port 1 or port 2 or port 3. I use only the one bit for connecting the switch or sensor, whatever it may be. Output is buzzer or LED, you can connect. Here LEDs are connected to the bits P1 and P2, right, and 805 on C program that shows the count from 00 to FF, that is in the binary 00002 to 4141 in binary on the LEDs. This is a header file because I am using the ports over here as define LED P2. The one way to define the port with assigned with some other name. This is a syntax as define LED P2. In the program you don't need to use P2, just you can use LED. Here there is no semicolon, that you have to be very careful. Sometimes some student has to be keep semicolon over here, it will show some error. Void main P1 I loaded with 00, X represent the hexadecimal. LED also I loaded with the X 00, it is hexadecimal. For in the bracket 2 semicolon I placed over here. This loop has to be run infinite times until you are switch on the system or switch on the simulation button. Okay, now we go for the simulation software to execute. I want to make 0 to 255 on the port P2 and P1. Now go for the peripherals. Further I have to be debugged. Yeah, port 1 already is there. I am going to take P2. P2 is assigned with LED. Okay, now I am going to execute stepwise 00. The next is 01. Again go for the loop, it is infinite. Again 1 1. Okay, this is 2, 10 is 2, the next 3 and so on until 255 times. You see port 1 port 2, I keep on sending 0 to FF 0 to FF. Okay, inside the for loop it is an infinite loop. I return P1 plus plus LED plus plus. Initially I initialize with 0 0, so after that it will get increment if it is in the inside the infinite loop. So it has to be, what is that, we keep on switch on and off the LEDs. That is on and off in the sense 00, 01, 02, 03, so on, according to the decimal hexadecimal values. The output over in the pins, particular pin, the corresponding LED is to be low. The next, the final program of IO port programming. It is a beautiful, why? Because it is a 32 IO lines. You can connect any input and output devices with the help of this 32 IO lines. Write an 8051C program to get bit P1.0 and send it to P2.7 after inverting it. Okay, get the input from P1.0 and send it to P2.7 after inverting it. Whatever the input you are getting from P1.0 had to be inverted and then sent to P2.7. So as include S bit, in bit I assign as P1 cap 0, out bit I assign as 2 cap 7. So these two are in the SFR the registers. The bit MEM bit is what is it? Simply I am using the bit, means it is the bit addressable in the random access memory, that is 00 to 7F, that is 128 bytes of RAM. The randomly pick the one single bit memory location. In that bit I am using MEM bit. Why? Because I want to invert it and then send to 2.7. So temporarily I want to be use this bit MEM bit. Here I should be inverted. After that I send to P2.7. So void main of while of is infinite loop, MEM equal to in bit. Whatever the input I am taking from the P1 cap 0, that is assigned with M bit. M bit, what is that? Has to be used this complement ME M bit. If it is 0, it becomes 1 after executing this instruction. After that you send to P2.7, that is that. Get input from P1.0 and send it to P2.7 after inverting it. Now I go for the Keil software to execute this program. So you are writing the program in embedded C, no need of knowledge about the hardware, the much knowledge about hardware details not required. Simply what are the input and output ports and what are the data types we are using and what is the header file and how to define the data types. Those things are very sufficient to run the what is that, write the embedded C programming. You no need of instruction set, assembly language programming or other information related to the hardware architecture doesn't require. Simple memory organization and data type is more than sufficient to write the programming embedded C. It is zero error. The same program I hope to not get copy and paste over here. Here is the program. There is a one error, that is the output. What is error? AS bit output is equal to P2 cap 7. So this is a complement of MEM bit. I hope here the semicolon has to become, yeah, fine. So rebuild and I go for here I am using the memory location for better understanding. I am using the memory location. It is a bit addressable. Already I told the bit addressable start from 0x20. Okay, 0x20 to 3F. It is a bit addressable location of the random access memory in 8051 microcontroller. So that's why bit MEM bit means it's going to be access the bit, a particular bit in the RAM location. Now I am going to run this program. The entire program I am running. Now I want to P1 cap 0. This P1 cap 0 is 0. So if it is 1, the inversion of 1 is what is that? It is 0. Now I am giving 1.0. So here is 0. Wait a second. Yeah, build, rebuild, and then come over here. P1 and P2.7. I'm going for stepwise. Okay, I'm able to get. So output is equal to complement of MEM bit. Initially in 20 it is a 1 over here. So I run over here. Have to be complement of this bit is replica in the port 2. Fine. The next same operation because I am not changing anything while of loop. So now I am making P 1.0 as 0. Now becomes it is a 0 over here. Now this 0 has to be invert and here 1 has to be come over here. That is the objective of our program. Yeah, 0. The 0 is stored in MEM bit. Input to 0, that is stored in MEM bit. After that it had to take a complement of that bit and send it to the P2.7, that is out bit P2.7. that is the replica over here. Fine. Keep on running. Thank you for watching.